Hello guys, my name is Saddam Leonardo Cap, and in this video I am going to talk about a very important concept in cosmology, and this technique is called Dynamical Stability technique, and we are going to study the dynamical stability in the context of quintessence. We have already talked about quintessence in detail. You can see those videos in the I button. The first question is why the dynamical stability technique is very important. We will see in a minute that why this technique will work, and this technique is always work. What is the origin of this technique? You have already heard about the butterfly effect, the chaos effect, or some nonlinear effect. In the nonlinear theory or classical theory, the dynamical stability is kind of very unique and very suitable choice. But in late 90s, people have started to apply this technique in the context of cosmology, and from there they have converted the complete physical phenomena into the mathematical one. And from this study, they understand each and every phenomena without worrying about the important physical aspects. Now we are going to study dynamical system in terms of quintessence. Therefore, first we are going to write down the action correspondence. So in our action, the first term is associated with Einstein equation. Then suppose the universe is filled with some kind of a matter Lagrangian, the matter field, because we have already known that the universe was first dominated with radiation kind of fluid, and then the fluid is known as dark matter and then dark energy. And then we can say that there is another component which is responsible for the late time acceleration. We are saying from L phi, and this L phi is we are considering to be some kind of a quintessence field, and this quintessence field is, and L phi is some kind of a quintessence field which is responsible for the late time cosmic acceleration, or it can depict the dark energy, and this is the Lagrangian is given by this one. So whatever the background fluid we are considering, it has to be some kind of a perfect fluid. So therefore what we are considering the universe has geometric effect from the Einstein's equation, and then we are considering that there is some kind of a background fluid. It could be the radiation type or any matter type, and then we are saying that the universe is dominated with some kind of an field which is responsible for the dark energy. Now if we vary this action with respect to field phi, then what we will get with respect to field phi, we will get the field equation corresponds to this kind of field, because this Lm is only consist of some kind of a rho and the number density and pressure and so on. It does not contain any kind of field variables. Therefore the field equation will become phi double dot plus 3h phi dot some potential dv over d phi is equal to 0. So this is the field equation. And if we vary this action with respect to g mu nu, this action is corresponds to g mu nu, then what we will get the energy momentum tensor of this field by something like this, square root of minus s ds over delta g mu nu. This is the complete stress tensor or energy momentum tensor in the context of some action. If we are doing this kind of variation of action with respect to g mu nu, so therefore in left hand side we will get the Einstein tensor, and in the right hand side we will get some kappa square term, this kappa square, and then this t mu nu. And this t mu nu consists of some kind of a matter field, whatever the matter, the Lagrangian matter, and as well as t mu nu which consists of the scalar field. Okay. And we already know that what is g mu nu? G mu nu is, we have Riemann curvature minus half g mu nu and then Riemann scalar. And if we take the G00, which actually enables you the Friedmann equation, 3h square is equal to some kappa square and rho total, which consists of rho matter plus rho phi. And similarly the another Friedmann equation we can get by Gij, the spatial component, which will give you 2s dot plus 3h square minus kappa square p of total. So these are pretty much basics, and for this we have used the metric to be, the line metric to be minus ds square is equal to minus dt squared a square function of time and dx square. Considering that our universe is flat geometry and it has homogeneous and isotropic in nature, and therefore this metric is corresponds to FLRW metric. I hope this is clear up to that point. Now with this we have additional one more equation which is also called conservation of energy momentum tensor, which is reading by now this one, and this is coming from the Bianchi identity del mu g mu. This is the Einstein-Sim curvature. So this has to be true, and therefore it gives you the two equations like rho m dot plus 3h rho plus p is equal to 0, and this is corresponds to matter field. Okay, so whatever the matter Lagrangian we have, this is corresponds to this matter. And then similarly we will have rho phi dot plus 3h rho phi plus p phi is equal to 0. This is the conserved equation. And now since our Lagrangian is basically minimally coupled, means that if you are multiplying with square root of minus g, they will actually enable you. You can see that Lm also consists of square root of minus g, L phi also consists of square root of minus g. So in some sense that all the components here are minimally coupled to metric. Therefore the individual stress tensor is conserved. Hence these are giving that how the energy density of the matter or the fluid and the field is evolving with time as the Hubble increases. So you can see that as this increases, this will decrease because it will go in right hand side, and with negative sign h increases. Therefore the change in rho m with respect to time is basically decreasing. Similarly you can see here this for the quintessence we can calculate rho by just simply writing minus T00 and pressure is TII. Okay, so if we are doing this kind of thing, then therefore rho phi is equal to half phi dot square plus V phi, and the pressure of this field will be half phi dot squared minus V phi. And previously we have talked about that it has given the equation of state P phi over rho phi, which is basically will give you half phi dot square minus V phi and half phi dot squared plus V phi. And we are told that if the observation has tells that omega phi is actually approaching negative of -1, and if to be true of negative -1, what we can do, we can simply assume that half phi dot square is very much less than V of the potential of this field, and therefore omega phi is equal to -1. Okay, but we can see here if we are not actually approximating it, we have this phi dot square and the potential, and in order to understand everything we have to understand what kind of field is, how the derivative of the field is varying and so on. So there are so many physical quantities are in there. Now we are going to discuss about the dynamical study concept. Okay, that how this dynamical stability is actually helping us to understand all the cosmology, that how the cosmology is if we have the one kind of fluid and the field which is responsible for the dark energy, because we can see that omega phi is negative of 1, and we don't have any pretty much idea that what happened to the if the universe was in very early state. We don't have any idea, so we want to translate it. So you have to see step by step how do I do and how we can think of it. So before we going to study what is the dynamical stability do, the dynamical stability tells you that define some kind of dimensionless variables. Okay, so here we have some theory and it says that define some kind of an x, y or z or any quantity which has to be dimensionless. Then what you can do, you can take the time derivative of this thing and it will enables you some kind of a function which is again depend on these only quantity, these dimensional quantity, like dy over dt is equal to gxyz or dz over dt is equal to hxyz. Okay, now here you can see that these are not time dependent, so they are not explicitly time dependent, but they are the time dependent in implicit form. Okay, so here nothing time dependent will appear, but x, y, z are the time dependent. So they are explicitly depend on time, but not dx over dt. F is not explicitly depend on time. Now these are called autonomous equation of any system. These are called autonomous equation. You choose the variable in such a way that no matter whatever the quantity you have, suppose we have in this theory we have rho phi, okay, we have p phi, we have omega phi, we have some kind of a rho matter, So these are the quantities which is very physical quantities. Okay, so we have to choose the variables, the dimensionless variable, in such a way that each and every variable can be expressed only these kind of chosen variable. And now you have to dump the physics and you have to just move on with the mathematics. Now when you are done with constructing your autonomous equation, what you can do, you can simply analyze the phase space, like suppose x versus y. This is called 2D phase space. And if you are considering x, y, z, then the phase space becomes the 3 dimension. And from here you will understand all about the system without doing anything. So and what is this x, y, z? What you can do, you want to find x, y, z by just simply doing f is equal to g is equal to h is equal to 0. So whatever the equation you are getting in right hand side, you have to just make it to 0. And after making it to 0, you have to solve for x, y, z, and you will get some kind of critical points. Okay, and these critical points will tell you different epoch of this universe. And then what you have to do, you have to check the stability of those critical points. Stability of the critical points. Now you can think about this thing. Suppose in the class 12 or in the early class, we have already told that if you take any kind of derivative and it goes to 0, it means that this is maximum or minimum. And then if you take the second derivative, we can say that okay, this is stable or unstable. So similarly, what we can do, we can simply f, g, h goes to 0, and then from there we can solve for x, y, z, and from there x, y, z gives you some kind of points. And these points are called critical points or fixed points. And after that, what you need to study, you need to study about those stability, because these points will indicate you about the different epoch of the universe. Like some points will correspond to matter phase, some points will correspond to inflation, or maybe some points are correspond to radiation and then late time acceleration. Now how to check the stability? To check the stability, you can define some kind of Jacobian matrix which says that you take df over dx, you take df over dy, df over dz. And similarly, you do the same thing with dg over dx, dg over dy, dg over dz. And then last, dh over dx, dh over dy, and dh over dz. Okay. Now this is the matrix, and you have to take this derivative with some kind of a critical point, whatever you will get. So I am doing it in 3 dimensions. And then after that, whatever you will get, you have to take the eigenvalues, and you know how to take the eigenvalue, j minus some lambda into I is the identity matrix, and 0. So because since these quantities will be so much difficult to handle analytically, you can do it with Python or Mathematica or MATLAB, anything, and they will simply give you eigenvalues. Now since this is 3 cross 3 matrix, what you will get, 3 eigenvalues, let us say e1, e2, and e3. Okay, and again for different components there are different e1, e2, e3, so for some particular critical points. Okay, and if you have 5 critical points in your system, therefore for 5 critical points there are different e1, e2, e3. Now the thing, if the real part, now these eigenvalues can be real or can be complex. Now if you are talking about complex, therefore it has some kind of an structure a plus minus ie. So what we have to see here, we have to see that either if e1, e2, e3, if all share the real components, real means that it will have some kind of 10 or maybe 10 plus minus ib or something. So you have to see the real components, and if all the real components are negative, then this is stable. So the corresponding critical point is stable. If any two are negative and one is positive, or if one is negative and any two are positive, or just no matter what, they have alternate sign in the real part, then they are called saddle. Saddle means that for some time this point, suppose this is the one critical point, so from far era some vector fields will coming towards, but this will after some time this will act as a repulsion point, and this vector field will diverge from it and goes to another path. So for some time it is behaving like an attractor, and then it will become repellent, therefore it is called saddle point. And then last is that if all the positive, if all the real parts are positive, then completely settle. Means that if any point, if there is a critical point here, then all the vector fields will not come here, but they will simply diverge from it. Okay, so they will never go there. So based on, so how we have determined? Actually, we have determined this using the Taylor expansion. Suppose fx is equal to this one, so fh plus some kind of an derivative with respect to x0, and then x minus h, and so on. So this f comma x, this is f comma x is saying you basically df over dx at x0. So from here we are getting the Jacobian matrix. So it is x plus h. You can say that x plus, sorry, this h is something called, let us say, delta x. Okay, so this is delta x, and this is delta x, x minus delta x. Okay, so basically this is giving you Jacobian matrix. And for 3 cross 3 system, if you have autonomous variable 3 cross 3, so we have f g h, therefore it is 3 cross 3. Suppose you have f and g, therefore it will be 2 cross 2, df over dx, df over dy, and dg over dx, dg over dy. Okay, and if you have 2 cross 2 matrix, therefore we have only 2 eigenvalues. And then same thing will apply, that if one of the eigenvalues has real part and is negative, therefore it is stable, and if they have alternate sign, it is saddle, and if any real part don't not have any negative sign, therefore it will become unstable, not saddle, it will become unstable, completely unstable. So this will tell you about every whole dynamics of your system, and then from there in terms of x, y or z, similarly omega in terms of x, y, z, this is called equation of a state. Similarly rho m you can write in terms of x, y, z. Okay, so from this x, y, z dynamics, because you know what you can do right after that, you can directly solve this kind of differential equation. And if you will solve this kind of differential equation, you will get some solution in x, some solution in y, and some solution in z. And from these solutions you can find that, okay, we have some physical quantities like rho phi, omega, rho m, some pressure quantities. Then you can find that evolution of these quantities like rho phi, rho m, omega with respect to time. And now since x has some kind of variation, y some kind of variation, z some kind of variation, and using the numerical analysis you will get some kind of a graph. And from this graph you will get to know everything, that how your model is working, what happens to the early time, what happens to lower time. So this is the complete picture of the dynamical stability. And now how to construct, now the point is that you have to again mind it, how to construct the dynamical variables. I had told you something very upper, that this is the scenario, but how you gonna construct x, y, z, and we are going to take an example from Quintessence. So in order to construct x, y, z, what you have to do, you have to first think of Friedman equation, and this is the Friedman equation. Now in our action you can see that we have 2 components. Okay, besides Einstein-Hilbert action, we have 2 quantities like Lm and L phi. And Lm and L phi is basically telling you about these things, like g mu nu has some quantity like 3h square is equal to kappa square rho total, and we have already told you that we have determined the t mu nu from these quantities. Now we are treating Lm to be this Lagrangian to be perfect fluid, and for perfect fluid we have t mu nu. So t mu nu is rho u nu plus rho plus p g mu nu. Okay, so from here we can simply say that rho of this fluid is rho and pressure of this fluid is p. Okay, and therefore I can label it as this one. Therefore since we have 2 components, we can simply express rho total in terms of rho matter and rho phi. And what we can do here, we can simply make it 1, and kappa square over 3h squared. I don't know what is my rho m, but rho phi I know. How? Because rho phi is, we have already tell you, it is half phi squared p phi. Okay, and now what we can see here, we can see that this will be 1 is equal to kappa square rho m over 3h squared plus kappa square phi dot square over 6h squared, and from kappa square v phi over 3h squared. Now this is the very much starting point. Now you can see here we have there 3 quantities and there is 1. Now this is one is dimensionless quantity. It means that all these things we have written here, they have to be dimensionless. So if they are the dimensionless, therefore this quantity is dimensionless and this quantity is dimensionless. Now I am proving that how this quantity is dimensionless. Okay. Now you see here. Now since xn is basically d4x is square root of minus g r over 2, let us say kappa squared. Okay. And then here some kind of a field, let us say L phi and Lm. Now you already know, now before we are going to use some kind of a natural units. Okay, these natural units are very much important because from here h bar c is equal to m. H bar corresponds to Planck and c speed of light is 1. From the uncertainty principle we know that Et is proportional to basically h. Okay, and we already know that E is equal to what? mc square, and c is basically 1, therefore E has some mass dimension, correct? Now if E is mass dimension, therefore E mass dimension and T is, and this is again 1, so T becomes mass to the power inverse dimension. Okay. Now similarly we already know that P into X is basically 1 or h bar. Now E is equal to what? E is equal to Pc, therefore P has the same dimension with energy, so I know P has mass dimension and X is 1, so X is again mass inverse. Therefore I can simply write that X, that is length, is equal to momentum is equal to time has the same as negative mass inverse dimension. Okay, this is very much important, this is very fundamental, and you have to understand it how to calculate these things. Now what is this is kappa, what is the dimension of this thing? First of all, this is the determinant of G and this is dimensionless quantity. Now you have already known that dx is the length, okay, and 4, so d4x is nothing but the mass to the power inverse and therefore the mass inverse, and this is the xn, and xn is a scalar quantity. Therefore if it has the dimension of m2 minus 4, therefore all the quantities here, they are basically mass to the power m4 dimension, correct? So what we are seeing that r over 2 kappa square, 2 is not a constant quantity, therefore it is m to the power 4. But what is the dimension of r and kappa square? So basically r is made up of d mu some kind of in gamma. Okay, now d mu is what? D mu is basically tells you about dx to the power mu in gamma, and again dx is length, and if you take what 0th component is time, and time and length has the same component, so it is basically 1 over m minus 1. Okay, and gamma is gamma, so this is m, dimension of m and gamma. But what is gamma? And gamma is Christoffel symbol, let us say alpha beta. Okay, so gamma is actually defined as half, let us say g mu nu and some delta g mu alpha beta. And g mu nu, they are again dimensionless. And what is dimensional quantity? This is d by dx, and this is sharing basically m dimension. So gamma has dimension is m. Therefore r has dimension m squared. So the dimension of r is basically m squared. So now it is clear. Okay, now we understand that r by kappa square is basically m4 and r has m squared, therefore kappa has to be 1 by m squared, then it will be equal to m4, therefore kappa has m dimension, not it is negative over n, because kappa is equal to 1 by m square, therefore kappa is equal to m inverse. Okay, so kappa is m inverse. Okay, now 3h square is equal to kappa square rho total, and rho is energy density, and we already know that energy density has mass to the power 4. Okay, now and we know that h square, what is the dimension of h square? Then kappa square is m minus 2 and rho total is m4, which is in total m squared, therefore h has m. Now we are talking about the field. Okay, because here the field, so how to find out the dimension of the field? Because s is equal to d4x square root of minus g and then half phi dot square or d mu phi. Now this is phi dot squared. Okay, so basically it is m to the power minus 4 and d phi over dt to whole squared, which I can write as m4. d phi is, I don't know what is this, but this is m minus 1 to the power squared, and let us say it is alpha, and m minus 4 into, so this will become m into alpha plus 1 to the power squared. Okay, so m to the power minus 4, and this is 2 alpha plus 2. Therefore this will be m to the power 2 alpha minus 2, and because we have to equate it, how we have to equate it like d phi, we have to equate it like m to the power 0. Okay, because this is, we are taking it whole, and s is m to the power 0, it is called a scalar. So 2 alpha minus 2 is equal to 0, hence alpha is equal to 1. So it says that phi has dimension. Okay, so we have the list here. Kappa is m inverse, h is m, phi is m, x and t is m inverse. Okay, rho is m4. Cool. Now any other quantity is left? No, I think so. R is m squared. If you have never found out what is the dimension of these quantities, so now you can have an understanding of this thing. And now I'm going to prove here that this lecture is going to be very interesting and but some kind of mathematical lengthy, but you have to watch it. Now you can say that okay, you have to be dimensionless. So what we can see here, like kappa squared phi dot square over 3 or 6h squared. Now kappa is m minus 2, phi dot will be, phi is m square, and dot will be, because this is 1, minus 2, and then h is m square. Okay, so this m square cancel out and this m is cancel out, therefore it is mass dimension 0. So now you have found out that this is the scalar. And similarly, kappa square by 3h square is m to the power minus 4, and here v is because potential and potential energy, and therefore it has mass to the power 4, and these guys are mass to the power minus 4, they will cancel. So we are saying that okay, this is the dimensionless variable, so I am defining x and I am defining this y, x square, or let us say this is y squared. Okay, so there is no any problem. So from the Friedman first equation, it will tell us that okay, these are the quantities which are dimensionless, and then we are first defining sigma square is corresponds to, because rho m, again rho m, you m to the power 4, and this is dimensionless quantity, so I am using sigma squared, and then some x square plus y square. Now you can see that if we have this x and y, and if we know x and y, then we can find the sigma. So sigma is depending on x and y, therefore we don't have to care about the sigma. So sigma square is equal to 1 minus x square minus y square. What does it tell us? That sigma square is corresponds to density of the matter, and matter is the real because it is a fluid, and sigma square cannot be negative, it has to be always between 0 and 1. It says that if x and y are 0, therefore 1 is the maximum that it can have the value. Okay, because sigma cannot be negative, sigma cannot be complex, therefore it has some boundation. Hence it is putting some kind of a boundation in x and y, that these has to be between 0 and 1. So our now x square y square is less than 0, 1. What does it say? It says that these x and y is taking the value between 0 and 1, and it is making a circle. So whatever the critical points that we are getting, they have to be inside this kind of circle. So if you plot x and y from the phase space, therefore they have to be lie in the circle, and from this circle we will get each and every understanding of the universe. And if any point is lying outside the circle, then we are saying that these points we don't care about it, and this is called the phase space constraint. Okay, this is the technique is called phase space constraining. So from here our phase space is completely constrained, and we don't have to care about it what is lying outside the constrained phase space. They are become completely unphysical to us. So now after that, therefore x square is equal to kappa square phi dot square 6x square, and y square is equal to kappa square v phi of 3h squared. Now what else? Now we can see the now if you will see that, you will find that if I am doing x dot, okay, suppose if I am doing x dot means the time, let us take time derivative. You know, phi dot is time dependent, h is time dependent, okay. So if you take the time derivative with respect to time, 2x x dot means dx over dt is equal to kappa square 2 phi double dot over 6x square, and then again minus 2 kappa square phi dot square over 6h cube, and then here I can say that h dot. Am I correct? Yeah, I have correct. So from here what we are getting that this x dot, they will contain phi double dot, and then again phi dot square, and h dot can be computed from the second Friedman equation, and second Friedman equation we have already written here that what is second Friedman equation, this one, okay. And p total we will now see that what will be the p total and so on, okay. So now we have to calculate where we can find phi dot. Okay, phi dot we have already computed from the action when we have varying with respect to phi, and if you vary with respect to phi, then we got this field equation phi double dot 3s phi dot plus dv over d phi. Now what we can see that phi dot we have already encapsulated in x, but dv over d phi we haven't, because we have only calculated the kappa square v over 3h square. But what happens to dv phi? So usually what we can define corresponds to this variable. One more variable is lambda, and lambda is basically defined as v comma phi over kappa into v. And what is v comma phi? V comma phi is basically tells you the dv over d phi and kappa v. Now you already know that v is m4 dimension and this is m minus 1, so they will make m cube, and again m4 and d phi is m dimension m cube, so it is becoming the dimensionless quantity. And if you are not considering any potential, now since if we will consider the potential, then you can easily find what is the lambda, and it is usually coming out to be some kind of constant. If you are not using the potential, then you can define one more variable which has to be again double derivative of v phi and then v comma phi square. Now v is m4 and double phi is m square, so m4 over m square is m square, and v phi square is m cube 6, so this is m 6. Therefore again if I am multiplying with v, therefore now our gamma is completely fixed. Any problem with gamma? No. So this is the gamma. Now what we can do here, we can simply find the autonomous equation. Now dx over dt, from here we can simply express phi double dot in terms of x and y. Phi dot can be written in terms of h dot, 2h dot plus 3h square is equal to minus kappa square p total. Now if you see that kappa square p total, one is p matter fluid and p phi, and if you will curious enough, then pm is equal to omega m is the equation of state, and then rho m plus p phi is some kind of an omega phi and rho phi, okay. Now if I'm dividing everything with respect to 3h square, then this is 1 and then minus kappa square over 3h square omega m rho m. Now rho m kappa square 3h square is sigma square, and sigma square is written 1 minus x square y square, plus omega phi is some kind of an, again either it will depend on something, or rho phi. Rho phi is what? Rho phi we have seen here, basically this one. How? Now if you will look here closely, this is the rho phi. Rho phi is basically half phi dot square v phi square, and kappa square 3h square by rho phi is basically telling you the x square and y square. So kappa square rho phi over 3h square is nothing but x square y square. Rho m kappa square 3h square is equal to sigma square, and sigma square is written in terms of x y 1 minus x square minus y square, correct. Now omega phi we have already defined p phi over rho phi, and this is guy is half phi dot square minus v phi half phi dot square plus v phi. Now if I am going to divide by kappa square by, let us say kappa square over 3h square, and then again multiplying by kappa and 3h square. Okay, so this is giving you x square minus y square and x square plus y square. Correct. So what we can simply say that 2h dot over 3h square is equal to, basically this is negative and negative, omega m sigma square, omega phi is x square minus y square, x square plus y square, and again kappa square rho phi is x square plus y squared, and this one will be some negative and negative minus 1. Correct. And they will cancel out. Therefore what we can do, we can simply write omega m 1 minus x square minus y square plus x square minus y square, and then if I am taking this inside the bracket, this is the guy, we will getting 2h dot over 3h square, completely in terms of x and y. See the magic? Now we do not have to consider anything about the approximation. Now we don't need to consider it. We have computed everything mathematically. Now we will do something with mathematics and we will find out everything. Now what we can do, what we can find is dx over dt. Now dx over dt we have computed here, which tells us that, where is this dx over dt? Is it gone? No. So this is 2x, but this one. So if you will do here, and you will get that there will be some kind of an, just by computing with x and all this and y, you will get that there is some kind of an h. So after doing the whole calculation, now I am not doing it, what you will get that dx over, you will get dx over h into dt, because h is time dependent and we have not given any kind of variable here, so it is better to take it outside and make it some different kind of a quantity. Okay, there is no any problem with this. Dx over dt will simply written as minus 3x plus root over 6 by 2 lambda times y square plus 3 by 2 into x into 1 minus omega m. Omega m is the equation of matter for the fluid, and 1 plus omega m, and then 1 minus y square. So now you are seeing that dx over h dt is completely dependent on x and y. Lambda is some kind of a constant, and lambda is the variable that we have already defined it. Okay, lambda is again one of the system. Okay, so we have basically three variables, x, y, and lambda, and we are assuming that gamma will be some kind of a constant because it will carry some number, because everything will be cancelled out and gamma is not depend on anything. So these are x, y, and lambda will be the basic quantities. Similarly, if you take dy over h dt, what you will get, you may get minus square root of 6 by 2 lambda x into y plus 3 by 2 y into 1 minus omega m x square plus 1 plus omega m into 1 minus y square. Let's see here. So this part is actually same as this one, and this is basically coming from, you will see, we will see after that, this is coming from this one, this equation. Okay, and after d lambda over h dt, it will give you minus root 6 lambda square gamma minus 1x, and gamma is, I have told you that it will give you some kind of quantity. In order to study this, you have to first assume that what is the potential. Potential is basically, in the case of quintessence, what they are defining, they define to be e to the power minus k kappa into delta times phi. Delta is some kind of an model parameter, phi is m, and kappa is m inverse, therefore it is completely dimensionless. So v comma phi will give you what? V comma phi, that is dv over d phi, is basically minus kappa delta e to the power minus kappa delta phi. Okay, and basically you can say that, okay, there is some kind of a constant which is v naught. So in this sense, gamma will be coming out to be 1 and lambda will be coming out to be some kind of a constant, which is basically, that is delta. Okay, if you do the calculation, so what does it mean? It says that d lambda over dt, if gamma is equal to 1 constant, therefore it becomes simply 0. So it has removed from our equation. So our equation is basically depend on dx over h dt and dy over h dt and x, y and so on. And lambda is just what? Lambda is simply constant delta. So you can choose anything, any value of delta, and you will get. Now what is the next section? We have to make it. Now this is, suppose dx over dt is f and dy over dt is g, and then we have to solve it. Solve for f is equal to g is equal to 0 and find out what is the x. And from here, what you have to do, you have to find out how you will extract some kind of critical points, and from the critical points you will analyze the Jacobian, and from there you will find the stability, and then from there you can find the phase space. Now I am going to simply go through the paper and will show you that what is the critical points and so on. So this is the quintessence, and here they have the Lagrangian half epsilon phi dot square. So epsilon we have taken is equal to 1, and they have taken the v phi is equal to v0 e to the minus k kappa lambda phi. So in terms of delta, they have taken lambda. So lambda is equal to delta, so there is no any problem. And you can see that what you have to do, you have to first find out. Now omega phi is already written in terms of x and y, omega effective is already written in terms of x and y, no problem. So now here you can see the critical points. This is the table for critical points. First critical point, they have named A, which is 0 0. Second one is 1 0, and third one is minus 1 0. Now why third one? Because you have this constant equation which structure is something like x square plus y square, correct? Now this one you can see x square plus y square, therefore x can take negative and positive. So this b1 and b2 both are the same points. And now another point is lambda is basically delta. This is not the lambda which is corresponds to this one. Lambda coming to be delta, and they have taken lambda to be delta is equal to lambda. So lambda over square root of 6, and y is something. So here both x and y potential are there. Okay, and then again lambda, and therefore some gamma. Gamma is corresponds to omega m. Okay, so gamma is 1 plus omega m. They have already defined here what is gamma. Yes, gamma is turned out to be 1 plus omega m. So in order to have omega m, in order to have omega 1 m is equal to 0, gamma is equal to 1. Okay, for if you have the pressureless fluid, so for pressureless fluid omega m is equal to always 0, therefore gamma is equal to 1. If I am talking about radiation fluid, then omega m is equal to 1/3, therefore gamma is equal to 4/3. Okay, so they have taken gamma, and y is again gamma. Now when they exist, these points will exist for any lambda and gamma. They have find out some constant, and again same as similar. But this point, x, y, and what is the meaning of existence? They have to be real. All the critical points do not carry any kind of complex quantities. They have to be real. So x, y, and y are real when lambda square has to be less than 6, and this point will valid when lambda square is greater than 3 gamma. Now here is the stability. They have not settled. Now these points become settled. X is equal to 0, y is equal to 0. Now what is happening if x is equal to 0, y is equal to 0? We have seen that sigma square is equal to x square 1 minus x square y square. If x 0, y 0, therefore sigma becomes 1, and sigma becomes 1, it tells you that sigma is dominating factor. Because sigma is 1, therefore whatever the fluid in the universe is present, it is dominating over the field, because x and y are field components, which tells you that the universe has some kind of an epoch where the fluid is dominated over the field. So field here is less dominated. Therefore this kind of solution where field is, if rho m over rho phi is greater than 1 or equal to 1, not equal to 1, greater than 1, where it says that rho phi is not dominated, rho m is dominated, it says that this is called scaling type relation. In scaling relation, all the fields have to be suppressed from the fluid. These are very technical points. Therefore this has to be settled, because we know that universe never settle in any kind of radiation, neither the matter phase. Therefore when this becomes settled, have the gamma is 2 and 0. Now gamma, we have already seen that if gamma is 1, then it is called matter epoch, and if gamma is 2, therefore omega m becomes 1, therefore then gamma is 2, and omega m is 1, it is called stiff matter. Now similarly x1 y0 potential is there is no any variable, or there is potential but the Hubble parameter is basically dominating, therefore y becomes 0 and x is 1. So this is again unstable node or fixed point or critical point, they are same. So they showed that unstable, when it will be unstable, when lambda or delta is less than square root of c, and saddle, this is again a saddle, and when lambda is greater than 6. Now we are seeing that again this will be same criteria, and c is now stable. Here this is stable. If this point is stable, it means that it is indicating that this is corresponds to the field, and field is dominating. Therefore what will happen, this is indicating that it is a accelerating solution. And from here the omega phi, what is omega phi? Omega phi is nothing but kappa squared 3h square rho phi. Okay, and this becomes dimensionless quantity, and they have labeled as omega phi, and omega phi is said that energy density of scalar field. So from this, for this point, omega phi come out to be 1, and why? And when this is 1, it says that the fluid is not dependent. But with this minimal coupling, we are actually seeing that omega phi is here also 1, and here is also 1. So omega phi is actually dominating, but it becomes unstable. So there exists because of the quintessence, it has some again different phase, different form of the solution, for which it will give you some unstable node or saddle point. Okay, and also it can become saddle for lambda square is less than 6 and 3 gamma. Again still omega phi is dependent, and for here gamma phi, you can see gamma phi is 2. So gamma phi 2 means that 1 plus omega phi, and omega phi is 1, therefore again it will become 2. So lambda square over 3, then again it can give you any value, and similarly this one. So we have 1 2 3 4 5 critical points. Now they have taken the phase space, because x and y, they are constant 0 to 1, 0 to 1, and all the critical points must lie between the critical points. So from here they are seeing that you take any kind of, they have not indicated the critical points here, but we will see in the different video that you can do, how you can draw, and all these things I will give you the detail. So here they will see that this is corresponds to maybe I think C. Okay, so they have choose that the phase space for lambda is equal to 2, means delta is equal to 2, gamma is equal to 1. Gamma they have chosen some stiff matter. The scalar field dominated solution C is saddle, x is equal to 2 by 3, it is saddle. Since D is stable spiral, and late time attracted is scaling solution with x is equal to y 3 by 8 to the power half. So what is basically showing that this is every trajectory basically repelling from here, and they are attracting towards this point, which says that every phase is basically acting kind of an unstable or saddle point, and they will converge to one point which is dominated by x and y, which corresponds to this thing, and this is the stable node. You can see here stable node, and this has gamma phi is gamma, so gamma is considered to be -2. Okay, and then you will find that it is showing you the accelerating solution, and they have given you that how the mu is corresponds to some eigenvalue and so on. So in the later video we will show that how to plot the phase space in dynamical stability. So phase space will tell you so many things about it, how the point is evolving, and then after that we will see that how rho m omega phi equation of state can be plotted. And I will ask you to again, there is one of my paper which is being published is in Quintessence, and you can take my code for this, how to plot, if you will even work in dynamical system. So but I will ask you one favor, that you have to cite our paper, and if you think that our paper is valuable because that work is very outstanding, so you can have too much idea about dynamical system and so on. So there are 2 or 3 papers, so you have to I will ask you for the citation and so on. So in later video we will see more about dynamical stability in different contexts like Quintessence and different thing. So I hope this I have tried to give you the glimpse of dynamical stability. It is a very powerful technique, so we will work on it. So thank you very much for today. See you later.